So let's discuss the first type of radical equation. We have discussed four types of equations that we will convert into basically quadratic equations. Now, the fifth type of equation that we'll convert into a quadratic equation to solve it is a radical equation. But we have further types in the radical equations. The first type is basically an equation like this. It only has one radical sign. A radical sign is basically this under root sign. And in the first type of radical equation that we'll discuss, it only has one under root or radical sign. And let's solve this by converting it into a quadratic equation. Now, what we'll do here is, as you know, 3x squared plus 2x is over here, and it is also over here. So what you'll do is you'll put 3x squared plus 2x equal to y, and now you'll have this equation here. Now you'll have to take the radical term, which is this term, on one hand, and all of the other terms on the other hand. So now what you'll do is you'll take square on both sides, and that becomes this equation here. Now, by subtracting, by not subtracting, basically, you'll just do minus 14 and minus y on this hand to get minus 15y, and plus 49 plus 1, which gives you plus 50. Now, this can be factorized to give you basically these two terms, y minus 10 and y minus 5. Now, either y minus 10 is equal to 0 or y minus 5 is equal to 0, and that basically gives you two values for y is equal to 10 and y is equal to 5. Now, we'll put y is equal to 10 in the equation that we made, which was 3x squared plus 2x is equal to y. So now, you'll basically solve this. Now, your very first step should basically be trying to factorize the equation, but if factorization is not really possible here, then you'll go for something like the completing square method or the quadratic equation, preferably the quadratic equation method in the other cases. So this will be quite difficult to factorize. We'll just use the quadratic equation here. Now, by plugging in the values of a, b, and c, which are these, you'll get, this is a quite lengthy solution, but you'll get basically two values here. One is minus 1 plus under root 31 over 3, and the other is minus 1 minus under root 31 over 3. So these are two values. Now, when you plug in y is equal to 5 in the equation, you get this. Now this here, this is easy to factorize. So you'll just factorize the equation, and now you'll get two terms, 3x plus 5 and x minus 1. So either 3x plus 5 is equal to 0 or x minus 1 is equal to 0. And now you'll get two values for x, minus 5 over 3 and 1. Now, extraneous roots. Now in the radical equations, in all radical equations, what you must remember is that they're deceiving. So what that really means is, we found four solutions before. Look, this is the first, this is the second solution, this is the third solution, and this is the fourth solution. But radical equations are deceiving. Not all of these are actually solutions to the equation. Why? Because some of them are maybe extraneous roots. What that really means, and how you check for them, is basically you'll plug the same values in the equation. The original equation that you had. Now, one of the solutions was x is equal to 1. You'll plug the x is equal to 1 into the original equation given in the question, and now you'll check to see if the left hand side is equal to the right hand side. Now when you solve this, this turns out to be true, so this is not an extraneous root. Now when you plug in another solution, x is equal to minus 5 by 3 in the same original equation that you had in the question, now you'll check again to see if the left hand side is equal to the right hand side, and then you'll solve this whole equation, and after that you'll get left hand side is equal to right hand side indeed. So this is also true. So this is not an extraneous root. Now the third solution that we had, we'll plug that in into the same equation. Now upon solving this, this turns out to be false because the left hand side is not equal to the right hand side. So basically this particular solution is not really a solution. This is an extraneous root. This is how deceiving the reciprocal equations are. Sorry, the radical equations, not the reciprocal equations. Now we'll plug in the fourth solution that we found in the same equation, and upon solving it, you get another false value because the left hand side is not equal to the right hand side. And so this particular term is not a solution, it is an extraneous root. So for all radical equations, you'll have to confirm if a solution is actually a solution or if it is an extraneous root. And you'll do so just by plugging in the solutions that we found into the original equation and check if the left hand side is equal to the right hand side. And that's it.